Hello friends, welcome to lecture number 22. In today's class, we'll read about resistivity. So before getting into this resistivity topic, we should understand what is current density. Current density is denoted by J vector and this is a vector quantity as it is shown. Okay. According to the definition, J is equal to how much? Current density means current per unit area. And in the last class, we have derived the expression for current and it was NEA. Vd was the drift velocity divided by A. So AA gets cancelled out. So J is equals to NEVD. Okay, vectorially if I want to write this, J vector will be NEVD vector. So this is the vectorial representation of your current density. Okay. Again, we also know the formula. We have also derived the formula in the last class. Drift velocity can be expressed as E capital E by M into tau. Okay. Relaxation time tau. So J will be how much? J will be NE instead of VD what I can write EE by M into tau. Okay. So J will be your NE square tau by M into E. Vectorially if I write, put a vector sign. So these are the two expressions which you remember for current density. Followed, and from the class 10th onwards we know that current density can be expressed as J vector is equal to sigma E vector. So if I give this as equation 1, this as equation 2, comparing equation 1 and 2, what we have, this sigma is what? It is called conductivity. It is conductivity. So if I am going to compare equation 1 and 2, what will be the value of sigma? Will be NE square tau by M. So this is your conductivity. And what will be the unit? Unit of conductivity will be how much? Ohm meter inverse. Inverse of ohm is called as mho, MHO, meter inverse. And this symbol is your MHO, mho. Okay, so this is all about your current density. And if you remember properly, another formula we have derived from Ohm's law, that R is equals to M by NE square tau L by A. This is the equation which we have already derived in the last class. And this we know R can be expressed as rho L by A also. So if you compare these two, what will happen? Rho is how much? Rho is your resistivity. Rho is your resistivity. And it is equal to how much? Resistivity, which is equal to M by NE square tau. And what is the unit? Unit of resistivity? Ohm meter. So if you look at this sigma and rho, what conclusion can you make? Rho is inversely proportional to sigma. So these are the very important things which you should know in order to solve many problems. Then let us go to the note. What all extra thing we know it? Note. From note what we have, your first one, R is your resistance. Okay. And what is the inverse of R? That is capital G, which is called conductance. Which is your conductance, that is equal to 1 by R. Okay. Third one, what is rho? Rho is equal to 1 by sigma. And rho is resistivity and sigma is your conductivity, as you know. Then the fourth point, this is very, very important. Fourth point, that the resistance of the material, resistance of any material, it depends on whom? Resistance of a body, a conductor, it depends on, resistance depends on the material, dimensions, temperature, and very important, direction of flow of current. Okay. So from this, R is equal to rho L by A. It depends on the material, temperature. We have to see how rho depends on temperature. We will see in the later part. So this is a very important thing, that it depends on, resistance depends on the direction of flow of current also. The fifth one, is your rho. Resistivity depends on the material, it depends on the material and temperature only. Okay. Now the sixth one, we have to know the relations R is equal to rho L by A properly. What is L? We usually tell L is the length of the conductor. Okay. But it is actually, it should be length of the conductor, length of the conductor along the direction, along the direction of flow of current. This is very important. Okay. And what is A? A is area of cross section. But how it is related to current? Area of cross section perpendicular to the flow of direction of current. Okay. So these are the 6 points which you should remember all the time. Okay. Now let us do some problems related to this formula R is equal to rho L by A, which will make you clear about the fourth point. What is the fourth point? That resistance depends on the direction of the current. We'll see how if we change the direction of the current, how the resistance changes. Okay. Let us do 3 examples. From there you will be clear. The first example which I am doing, suppose we have a cube of different lengths. Okay, this is your A, this length is A, this is B, okay, and this is your C. Followed. Now I will change some situations. What change I will tell? Suppose current flows in this direction, current is in along this direction. Then what will be the value of R? R will be rho A. A, why? Because L has to be the length of the conductor along the direction of the flow of current. So current flows in the which direction? X direction. X is A here. So rho A divided by BC. BC is the area. Okay. Now for the second situation, again I will take this where the sides are ABC as usual in the previous one. Only difference, this is A, this is B, this is C. The only difference is the current direction. I'll change the current direction and I'll see whether the resistance changes or not. Now the current direction is along like this. If the current direction is along this, R is equal to rho B by your AC. Okay. Now suppose if the current is into the plane of the paper, okay, into the plane of the paper, then rho R will be how much? It will be rho C by AB. So we see here in this example, particular example, if the current direction changes, the same conductor you take, cube of different lengths, then what you see? The resistance is going to change. So basically we can make a concluding line that resistance depends on the current direction. Okay. Now your resistivity also depends on temperature. Let us see how it depends on temperature. So give a heading, temperature dependence of resistivity. Okay. So looking into the formula also we can see how it depends. We know the expression for rho. What is rho? Rho is equal to m divided by n e square tau. Okay. Now if I am going to increase my temperature, then it is quite obvious that more will be the collision. So tau is going to decrease. If tau decreases, then what happens? Then tau is inversely proportional to rho. So rho has to increase. So basically with increase in temperature we find rho also increasing. This is very important question, viva question, which we usually ask in the practical exams. Okay. Now how this resistivity is related to temperature. Okay. From experiments it was found that the resistivity of a material is found to be dependent on the temperature. Okay. So how it is related? Rho T is equal to rho naught 1 plus alpha within bracket T minus T naught. So this is the expression for your resistivity variation with temperature. This is very very important. Many problems come for this. So you remember this one. So now you need to understand what is rho T. Rho T is your resistivity at a temperature capital T. And what is rho naught? Resistivity at a temperature T naught degree Celsius. Okay. Then what is alpha? Alpha is your temperature coefficient of resistivity. Question comes, what is the unit of alpha? Unit is degree Celsius inverse or Kelvin inverse. And what will be the dimension? Dimension will be T minus 1. Okay. So this is all about this formula. There is also another formula by which you can another definition for your temperature coefficient. Okay. So alpha is can also be defined as the change in resistance per unit original resistance per degree rise in temperature. So if I write it mathematically, so your alpha will be equal to R2 minus R1 divided by the original resistance, that is R1, T2 minus T1. Okay. Now if my T1 is equal to 0 degree Celsius and T2 is equal to T degree Celsius, then alpha will be is equals to 2 means T I have to substitute. So RT means resistance at temperature T degree Celsius minus R0. R0 means resistance at 0 degree Celsius divided by R0 into T. So if I expand this, my RT value will be how much? R0 1 plus alpha T, which is of the same form as that of the resistivity what we have got it here. The form is same. So these two formulas you need to remember. Problem comes. Okay. Two very important problems which are the examples of your NCERT book that I am going to do. I will discuss now. The first one is like this. This example you can check it from your NCERT book. So it is given that the resistance of the platinum wire of a platinum resistance thermometer at the ice point, okay, at the ice point is 5 ohm, and at the steam point is 5.23 ohm. Okay. Now what you do, you take the thermometer and dip in a hot bath. In doing so, the resistance of the platinum wire is 5.795 ohm. Okay. Calculate the temperature of the bath. Very important question which comes in the exam. Okay. So how to solve it? Let's see. So what things are given? At ice point, what is the resistance? 5 ohm. At steam point, what is the resistance? Steam point is 100 and ice point is 0. Already we know it from thermodynamics in class 11. So 5.23 ohm. Okay. Then some arbitrary temperature is how much? At arbitrary temperature, what is the resistance of the platinum wire? 5.795 ohm. Okay. Now we will use the relation RT is equal to R naught 1 plus alpha T. Okay. So now we can say RT minus R naught is equal to R naught alpha T. Just I have taken the R naught to the other side. Now if I this is a relation which I got just because between your temperature T and your ice point. Then between steam point and your ice point, what it will be? R naught alpha T will be how much? 100. Okay. So these are the two equations. Now divide both the equations. 1 by 2 you do. If you divide it, you will get RT minus R naught divided by R100 minus R naught is equal to T by 100. All rest all will be cancelled out. So what will be your T temperature of the bath? Will be how much? It will be T100 is how much? 5 point. You will get T100 will be how much? T will be equal to RT minus R naught divided by R100 minus R naught into T. This much will be your value. So what is RT here? 5.795 minus 5 divided by 5.23 minus 5 into 100. If you solve this, the temperature is going to come out to be 345.65 degrees Celsius. So this is a very important one. Okay. So I hope everybody must have liked the video. Do share it. Do not forget to subscribe it also. Any queries you have, you can just mail me in the mail ID which is given below. Okay. Thank you for your kind patience.